Good morning, students. We were doing the chapter, as you know, the elements, compounds, and mixtures. And since we were, or rather, we are having the classes directly, so today I thought that instead of discussing some of the topics of the chapter, so I'll rather discuss the exercises, the question answers straight away. Okay, I'll discuss the question. So I thought before, as if I discuss the other topics, though we are almost approaching towards the end of the chapter, so I can discuss the rest of the remaining chapter over the live sessions, the classes which we are having. So over here, so today we'll discuss the question answers straight away. So let's begin. As we are having the mixtures written over there, so it's not a we were doing mixtures, so I've kept the topic over here unchanged, and it's a part of the chapter also. So I'll start with the exercises. The first exercise, the first exercise which we're having, uh, exercise 3A. Probably if you have noticed, we are having only two exercises of this chapter. Exercise 3A and exercise 3B. So two exercises are there. So let's begin. The first question, as it says, that define elements and define compounds. Definition of elements we have discussed, and I hope you will not face any problem with this question. The reason is because this definition of element, though it's straight away given in the book, also we have discussed, or I've discussed separately in my previous lectures. So the first definition, as it goes, we can write that element is a pure substance which cannot be converted into anything much more simpler. So elements are pure substances which cannot be converted into much more simpler substance. It contains particles. It is made up of particles, and all the particles are similar. That means they are made up of similar type of particles. They are basically, the composition is homogeneous. That means throughout the element, you have noticed that throughout the element, all the atoms or the particles are the same, and that is basically examples are must. So you should give examples in hydrogen, oxygen, sodium, whatever. Coming to the next question, that is compounds. Compounds, as it said, that compounds are made up of different type of atoms. They are pure substances, of course, and the atoms are belonging to that of elements. So since element is a pure substance, hence composition is also. So definition wise, compounds are composed of different type of atoms of different elements and is a pure substance, homogeneous in nature, sorry, not homogeneous, and the properties of the atoms of the elements belonging to the compound are different from the properties of the compound. Example, water. Hydrogen is one of the atom present element, another element oxygen, and the properties of hydrogen and oxygen totally differ from that of the properties of water. Moving on to the next question, give two examples for each of the following metals. Well, we have to give examples of metals. We know that sodium, magnesium, aluminium, calcium. Non-metals we are having, that is oxygen, nitrogen, fluorine, chlorine. Metalloids, silicon, we are having boron, you can say, and so the two metalloids present. Then followed by inert gases, it's helium, neon, and argon. Differentiate between pure and impure substances. Differentiate between pure and impure substances. That's a question given. We know that pure substance basically It is having a definite composition and definite physical and chemical properties, and it is of course homogeneous in nature. And the next is impure substance. Impure substances are basically made up of two or more pure substances mixed together in any proportion. They do not have a definite set of properties, and they retain the properties of the component by which it is made up of. So you'll give examples of pure substance. You can give as if elements, gold, oxygen, and all this stuff. And you can also you have to give examples of impure substances. So better to give examples of mixtures rather. So you can give water, you can give air, all the stuff. The next we are having, write the chemical name of the following and also give the molecular formula. Baking soda, the chemical name is sodium bicarbonate. Molecular formula NaHCO3. Vinegar, the chemical name is acetic acid. The molecular formula is CH3COOH. The next we are having marble, the chemical name calcium carbonate. The formula CaCO3. Sand, silicon dioxide, chemical name, and formula SiO2. The next question, a soft metal, sodium. A metal which is brittle, zinc. A non-metal which is lustrous, iodine. A liquid metal, mercury. A metal which is a poor conductor of electricity, tungsten. A non-metal which is a good conductor of electricity, I'm forgetting that one, no, good conductor of electricity, a non-metal, that's graphite, yes, graphite. The next, a liquid non-metal, bromine. The hardest naturally occurring substance, diamond. An inert gas, helium or argon or neon or krypton, xenon, whichever you feel like. The next question is, how is sodium chloride different from its constituent elements? I'll explain this one, but with this question and the question which is followed by, that is, why is iron sulfide a compound? These two questions and few others, I'll definitely provide you the answers. But before that, I'm going to explain this one, that how I've discussed this one previously, but once again it will be a recapitulation. How is sodium chloride different from its constituent elements? The answer is, sodium chloride is made up of element sodium, which is a metal, and chlorine gas, which is a non-metal. Now, sodium is a highly reactive element, which is a metal as well as solid, and it catches fire when it comes in contact with water. Chlorine, it's a gas, and it is having a greenish yellow color, and it is poisonous in nature if inhaled. Now, sodium chloride, it is a white crystalline solid which does not catches fire when it comes in contact with water, and it is not at all poisonous in nature, and hence sodium chloride is different from its constituent elements. The next, why is iron sulfide a compound? Iron sulfide is made up of iron and sulfur, two elements of which one is a metal, bracket iron, and the second is a non-metal, which is a sulfur. Iron is having luster, and it is a very hard substance, and it attracts magnet. It is having magnetic properties. Sulfur, it is amorphous in nature. It's an amorphous solid, yellow color, and it is poisonous in nature. Sulfur is poisonous. Regarding regarding iron sulfide is a hard solid crystalline but black in color, and it is not having luster, and it is not showing does not show us tremendous amount of magnetic properties. So thus the properties, due to the difference in the properties of its corresponding elements, it is a compound. Clear, everyone? So these were the questions related to exercise 3A, and if you're having confusions or queries, you may ask. But I repeat, some of the questions I'll definitely provide you the answer so that you become familiar with how to attempt a question or how to write an answer. Okay? Alright. Now, moving on to the next exercise. As we have completed this exercise, I'll switch over to the next exercise now. That is exercise 3. Here there is almost 6 questions, but every question is having subdivisions. So let's get started. The first question: classify the following substances into compounds and mixtures. Classify the following substances into compounds and mixtures. The first is carbon dioxide. It is a compound. Air, mixture. Water, compound. Milk, it's a mixture. Milk, do not classify this one under the heading of compound. Milk is not a compound. Why milk is not a compound? Because though the core ingredient of milk is a compound, but that's a core ingredient. But milk is, when we write milk, we do not specify that particular core ingredient. Milk basically is composed of minerals and various vitamins, proteins, carbs or carbohydrates, fat, and each and every this class of compound is retaining its individual properties. So though milk, it is a mixture, rather though milk, it's basically one core ingredient is the compound, but since it's a mix of all the different compounds, and all the different compounds are having their individual properties, they're retaining that one, hence milk is a mixture, not a compound. Common salt, compound. Blood is a mixture, blood is not a compound. The next, fruit juice, it's a mixture. Iron sulfide, compound. Clear? Alright. Give one example. Question number 2. Give an example for each of the following types of mixtures. Solid homogeneous mixture. So definitely it's a category of the alloys because it's a solid homogeneous mixture. So alloy section, so you may give an example. So don't write alloys, okay? That's not an example. That is a class of compounds. So better to write brass, or bronze, or any other alloys which you have idea. It can be duralumin, it can be magnesium, it can be gunmetal. So there are a list of alloys are there. So you can write any of the one, your choice. The next we are having solid liquid heterogeneous mixture. Solid liquid heterogeneous mixture. Now that is, you can write sand and water, solid liquid, the simplest of the example. Sand and water is solid liquid heterogeneous mixture. An example of miscible liquids, so you can go for water and alcohol. You can go for juice and water. You can go for kerosene and petrol together. So there are many, whichever you are comfortable with. The next question is liquid gas homogeneous mixture. So that's the best thing is soda, the soda drinks. There is basically liquid gas homogeneous mixture, soda drinks which are available. It can be a normal cold drink, or it can be the soda water bottles, or the drinks which were available so in the markets. So those are basically liquid gas homogeneous mixture. Okay. The next we are having separation techniques. Suggest a suitable technique to separate the constituents of the following mixtures. Also give the reason for selecting the particular method. Now, when you are writing, this question is there, and we have asked this question, that the reason, you have to state the reason. Also give the reason for selecting the particular method. This particular method, or this reasoning, please don't write that one is like that way, that one is solid. So you have to basically don't write that one is solid and one is liquid. This basically mention the reason is the best way to answer this is to write the principle. That is, suppose, let me give you an example to understand. The question is salt from seawater. Salt from seawater. So when you're having that salt from seawater, that means there is a salt which is a solid one, and seawater which is a liquid one. So it is having one solid, one liquid. Now think of in which separation technique we normally use this principle, that one, or rather we normally if we find that one solid and one liquid is there, we will definitely use that one conditionally, that the solid is a soluble one. So the exact condition, it's a soluble solid and a liquid with a soluble solid. What separation technique we normally prefer to use, rather to separate these things together? So since it's focused that only we want the salt, because the first thing is the salt from seawater, it's not mentioned that both the components. Okay, it is not mentioned to separate the constituents. Now there is a confusion. The confusion, you may feel that the question is to separate the constituents, plural given. So whether you will be separating the salt from seawater, or rather only the salt, or you will focus on the liquid also. So since the question is about, if you focus the question of constituents, so the plural, so you may, based on that, you may separate both. If you only focus on the first one, as per the question means the subdivisions, the components which are given, only the first part, then definitely you may choose your favorable method, whichever is applicable. Alright? First, it's given salt from seawater. So there are 2 points. Either I will be focusing only on separating the salt. So what happens to the seawater, I don't mind, or the water. Or I will be focusing on both, that I want the salt as well as the liquid water. So if I consider only the salt, so then I'll go for evaporation, the separation technique. So on the left you will write salt from seawater. The second column will be techniques of separation, so you will write evaporation. And the third column you will write reason. Over there, soluble solid in a liquid. Reason is for considering this particular method, it's soluble solid in a liquid, or to separate a soluble solid from a liquid. Or you can also go for, what is another point? You may also write salt from seawater. That is evaporation followed by distillation. Evaporation followed by distillation. So the first soluble solid from liquid followed by the liquid, which is from the condensing the gases into its corresponding liquid form. So if you write like this way, it will be a very clear picture that why you are using this particular method of separation. The next we are having ammonium chloride from sand. Ammonium chloride from sand. So the best part is going for sublimation, because sand, it's insoluble. Sand, it is so we will not have any sort of soluble substance over there. Rather, sand will not be soluble. Moreover, sand does not sublime. So the best part of getting this one is ammonium chloride is sublimation. So ammonium chloride, if we heat the mixture, the ammonium chloride will sublime. So we're leaving behind the sand, and we'll get back the ammonium chloride if we condense the vapors and separate it. Chalk powder from water. The best part is filtration. We will not go for any sedimentation or decantation, all the stuff. The best is filtration. Iron from sulfur. So since iron ore is having its magnetic properties, we know I mentioned previously also that if we know certain properties of the particular components which are present in the mixture, it becomes easier for you and for us to separate the components of the mixture. So now this is chalk powder from iron from sulfur, some magnetic separation. Water from alcohol, rather water and alcohol. The mixture is given water and alcohol. Will go for fractional distillation. Fractional distillation. Sodium chloride and potassium nitrate. Sodium chloride and potassium nitrate. Now, since both are having what should I say? Both the solids are soluble in water. Both the solids are soluble in water. Now, what technique we will normally use? The method of separation for this sort of things will be crystallization. The best part is go for crystallization. When both you're having, I explained that one previously also, crystallization, but not normal, fractional crystallization. The best part of this one will be fractional crystallization. Okay. The next we are having calcium carbonate and sodium chloride. Calcium carbonate and sodium chloride, one is soluble in liquid, another one is insoluble one. And we know that solvent extraction, the principle, that over there, two solids will be there and heterogeneous mixtures, and definitely one will be a soluble one and another one will be an insoluble one. So solvent extraction is the method of separation for calcium carbonate and sodium chloride. The next we are having the question, define a mixture. Now this question is a straight question given from the book, and as well as this question I have discussed personally, so there shouldn't be any confusion regarding that one. Okay, you know this very well. Define a mixture. That's a state of matter which is formed by mixing two or more substances, and basically pure substance, and then all the substances do bear their individual properties. And hence it's called a mixture. I've just given you a very short introduction to that, but definition I've explained that one earlier. So along with that, examples must. Why is it necessary to separate the constituents of a mixture? Why is it necessary to separate the constituents of a mixture? It's basically, the reason is, if we suppose there is a mixture and we need one of the components of that one, it is very important to separate. Number one, it's purification, because if two or more substances are present and we need to remove one substance because we need to make that substance pure, because one of the components is acting as an impurity. So for that reason, separating the constituents of the mixture is very, very important. So for this reason, it is very important to separate the constituents of a mixture. The next we are having the question, state four differences between compounds and mixtures. Now this particular question, most probably, if I'm wrong, maybe I've given in my video lecture, difference between compounds and mixtures. If I have not given this particular difference between compounds and mixtures, then it's given in your book, but I am very much sure that I've given in my video lecture. You might follow that one, or it's also available in your book. Four differences given, so it's a direct question from the book. The next is, what is chromatography? Now there's a definition. It's I've already discussed previously. I'm discussing once again. Chromatography, it is basically a separation technique based on the difference, based on its colors. That means the components when it is separated, they get separated out and they reflect its individual colors. And based on the individual colors and the position of the colors, the individual substances are being identified. So chromatography is a separation technique where a mixture, a homogeneous mixture, of course, a homogeneous mixture, and rather to better to say liquid homogeneous mixture, or it's basically not applicable for solids, but it's applicable for solutions. So a solid liquid or a liquid or a liquid gas. So whatever, apart from solid, homogeneous and heterogeneous mixtures, the rest of the mixtures, depending upon the composition of the mixture, this chromatographic technique can be utilized. So depending upon the colors which it's normally reflect the components which are present in the mixture, the chromatographic separation technique is utilized. So once again I repeat, it is basically a separation technique. Chromatography, it is the word itself means to write with color. So writing means it is a separation technique in which the components get separated, or when they are, or the components get separated based on the difference in their two phases. Okay, it's a separation technique where the components get separated based on the difference in the two phases, of which one is the stationary phase, the other one is the mobile phase. For which type of mixture it is used? It is used basically between homogeneous mixtures. It's basically utilized for a homogeneous mixture. Or you can also write in a very simple note, similar mixtures where the components are having similar properties and homogeneous in nature, apart from solid homogeneous mixture. Now, what are the advantages of chromatography? There are many advantages are given in your book. So one is the small quantity of the substance can be separated. The components basically are of similar chemical properties, they can be separated. It identifies the different components of the mixture. So there are a lot of properties given in your book. You can go for that one. Give the applications of chromatography. Number one, it's helped in the separation of dyes, and it's helps in the separation of the drugs from the blood. And of course, another one to identify and to distinguish and to separate the pigments of colors, different colors and natural colors, whatever. And another one is to purify substances, natural industrial substances or industrial products. We need to purify that one. So chromatographic techniques is also used to purify, because once we separate those ingredients, so it will be easier for us to apply the separation technique or the purification technique. Choose the most appropriate answer from the options given below. A mixture of sand and ammonium chloride can be separated by sublimation, of course. Now, a pair of metalloids boron and silicon. Which of the following property is not shown by compounds? Not shown by compounds. There are four properties given. So compounds, they are heterogeneous. So compounds, they are homogeneous. They are heterogeneous. They are homogeneous. They have definite molecular formula. They have fixed melting boiling points. So out of these, it's not shown by compounds. Compound is heterogeneous. Sorry, not shown. So compound, they are homogeneous. Compounds are not homogeneous. They are heterogeneous. They have definite molecular formula. They have fixed melting and boiling points. But compounds are not homogeneous. Similar atoms not found, so they are not homogeneous. Compounds are heterogeneous. Okay. So the next question we are having. Sorry, I got that one mistaken. Sorry, compounds are not heterogeneous. So compounds are not heterogeneous. So compounds, they are always homogeneous. So compounds will not be heterogeneous. Okay. So compounds are homogeneous. So which of the following property is not shown by compounds? That answer will be they are heterogeneous. Compounds, they do not show the property of being heterogeneous. Compounds that do not show the property of being heterogeneous. Okay. They are homogeneous. They show the property of being homogeneous. They have definite molecular formula. They have fixed melting and boiling points. The next is a solvent of iodine. A solvent of which is a solvent of iodine. Within this, iodine is soluble in alcohol. So iodine is soluble in alcohol. The next is which of the gas is highly soluble in water? That is highly soluble in water. You can write oxygen, you can write ammonia, but over here the best answer will be ammonia. Which of the gas is highly soluble in water? It's ammonia. So the answer is ammonia. Which of the gas is highly soluble in water? The answer is ammonia. Alright. So with this question, I have completed discussing the question answers related to this chapter, and I do one or two questions are here which needs support. So I'll provide the answers to those. Apart from that, if I find any other different suitable questions, definitely I'll give those questions to you, and few other questions maybe related to this chapter, and those questions which are not mentioned in the exercises. You will find those questions definitely in the quiz section, or the verified knowledge, the quiz section which I normally give. Those are which are given. So please, I'll request all of you to practice those quiz portion, because questions, though they are pretty short questions which I normally give, but they are related to this chapter, and there are different sort of questions which are provided to you which are not mentioned in this particular these exercises. Okay, so with that, I would definitely like to conclude my lecture. So thank you so much. Stay safe and take a very good care of yourself. Thank you.